In this tutorial, we will learn to use the environment layers here in the environment menu to improve the accuracy of our planning. Now, so far you've seen demonstrations using LiDAR layer only. So that is the surface elevation, which is a digital surface model, and it looks like this. So it's fairly crisp, and you're getting not just buildings and the shadows, but you're also getting trees and shadows caused by tree lines. Not everywhere in the world has LiDAR data, but we do have global data in the form of 10-meter land cover. So if you were to use terrain data instead, because you did not have LiDAR data, you can expect to see coverage that looks like this. So it's smoother, it's not as sharp, and there's not as many voids and nulls in the coverage there. But despite having this basic data, we can improve upon this using the other layers, which we'll go through now. So if you have a terrain layer, we can see that in the profile using the Path Profile tool up here. So if we click the ruler, click somewhere that we want to observe, and we can get a terrain profile. So in that terrain profile, we can see the hill, and that matches with the coverage. Onto this terrain profile, we're now going to add land cover. Now, land cover data, it's global, accurate to 10 meters, tells you the difference between trees, roads, water. And now we've layered on 10-meter land cover, and we can see some colors. Red is urban, you can see the water down here, you can see some trees, fields, and then agricultural land over to the east. So what we're now going to do is repeat this area calculation, but with land cover on, and compare the difference. And now we can see that it's changed the coverage. So we've got a difference in coverage out here to the east. And now that the coverage has been changed, let's go and add on another layer, this time buildings. So we're going to bring in some third-party buildings and place them upon the land cover. So let's put them on here, and now we've got quite a drastic change in coverage. And the reason is because there's some significant buildings down here and they're blocking the signal. So we have enhanced the land cover by placing land cover and buildings upon the terrain. And the grey buildings you can see here. We're attenuating through the obstacles with a value that's defined in our profile, in this case the minimal profile. We can tune the land cover therefore by opening up the profile manager here, which is the tree icon, and we can have a look at our different profile settings. So we have 9 types of land cover. The building attenuation value here is 0.5 decibels per meter, mean attenuation. So we can play with this and create a new profile. So I'm going to create a profile. I'm going to call it Gloss 1. I'm going to set the attenuation to 0.1 mean attenuation. I'm going to make the trees bigger, 8 meters tall. And I'm going to make the urban areas slightly larger at 2 meters. And that's all. So I'm going to save that. That's Gloss 1. Now, change the profile to Gloss 1 and repeat. The expectation here is that the trees will become more challenging. The big buildings will become less challenging because we'll make them a little bit more permeable. And by doing this, we're playing with the coverage. So first of all, let's look at the trees over here. You can see we're attenuating into the trees when we're hitting them. Those trees are having quite an impact. And if I put my ruler over here into the trees, we can see the trees on this hill. So not only have we got trees, but we've also got a steep hill on the side of the river there. And we're going further beyond the buildings now that we've changed the building attenuation. So with this we can tune to a region, we can tune to an environment. And we can do that for anywhere in the world. But what if we want to model something very precisely at greater than 10 meters? What if we want to model an actual building which has been constructed? So we're going to work on a hypothesis here that there is going to be a new construction, because I can see a wind farm over here. We're going to add something new on the dockside here, a new building. And to do this, we're going to draw it as a custom clutter, or my obstacles. So what we need to do is first of all identify what material we're going to be building with. So it'll be one of these 9. So we could either create a new material and save it as a profile, or we could just pick one of the existing ones. Well, my building is actually going to be 20 meters tall. It's going to be significant. So I'm going to need a new profile. I'm just setting up the trees as they were before. I'm going to set up for a 20-meter building. It's going to be very dense, and I'm going to save that now. Now I select this profile and I get ready to build. So to build, we click the pencil icon at the bottom here, draw obstacles, select the matching code. So we've got the 9 codes here which correspond with the 9 codes that were on the list there, so it's concrete plus. And I'm going to draw this tower right here on this piece of land. So this is a 20-meter tall tower. Click the cloud button, upload it to the profile, and we have drawn a 20-meter tall tower which we can verify visually. But we're not done yet. Now let's switch the layer on as my obstacles, check the resolution, that'll do, and model it and see what happens. Okay, the tower is now casting a large shadow, because if we switch the layer off and repeat, we can see that there's coverage all the way down to there. But with the tower, we're losing all that coverage. And with custom clutter, we're not bounded by the resolution of the reference data that we're using. So I don't need to bound myself to 10-meter data because I'm using 10 meter. I could ask for 2 meters. Put the layer on. I'm just going to reduce the radius so we don't have to wait as long this time. And now with the layer on, we're getting a 2-meter accurate shadow off that obstruction and beyond. As well as being able to draw individual obstacles, you can upload KML or GeoJSON files to describe multiple obstacles. To do that, set up a profile as you did before. So in this case, I have created a profile because I want to draw some 25-meter tall wind turbines. So I entered 25 into here and I saved it as a new name. Now select that profile from your list and go ahead and upload the file. So in this case, the type is code 9, which is metal, and I'm going to choose a file off my desktop. I'm picking a KML file containing 3 polygons, which have now appeared on the map, and I click push the clutter to push it to the account. Okay, we have 3 metal obstacles here, 25 meters tall, and the 20-meter tall concrete obstacle that we drew earlier. Okay, so to do a A/B comparison, I'm going to switch my obstacles off and create a coverage layer, and then we will repeat with my obstacles on at 4-meter resolution, and we'll see what the impact is. There we are. So that is how you upload and manage custom clutter for KML and GeoJSON with custom heights and profiles.